Hi ladies, so we are looking at flowers and fruit. This is one of the last bits we're doing for P1, so you're almost there, so bear with me. Now, having a look at our diagram here, we've got three main parts of our seeds, okay? We have the seed coat, which is the coating around the seed. So it stops the seed from getting water prematurely because we don't want the seed from any moisture in the air will germinate it and stuff like that. So when we have different plants have different seed coats, clover and lucerne, they have quite hard seed coats so that not all of the seed germinates at the one time. Okay. Now we also have the endosperm. So if we're looking at corn, the endosperm is the big orange bit. Okay, now down in the very base of a corn kernel, we have the embryo. Now the yellow bit, the endosperm, is basically, it is just starch, which is glucose. All right, so it is used for the growth of the young plant. So it'll germinate, it'll be using all of the energy supplied in the endosperm, and that's what it is there for. It is also the main thing that we're chasing when we're harvesting grain crops. So wheat, corn, barley, we are chasing this endosperm. It has all the energy that we use, okay? Now the embryo is basically, you know what an embryo is, it is a young life. So basically the embryo is the small plant that is ready to germinate. Okay, now germination, we're going to talk about this later on in another dot point, but basically germination, it happens when water goes into the plant and it starts off a chain reaction that leads to the plant, the seed taking on water, and then growth happens. So we'll have a shoot appear and we'll have root appear out of the embryo. Okay, I don't think we need to go into anything here. Oh, it is interesting. So different plants have different sorts of flowers and seeds and stuff like that. So nuts are a seed. We know corn as a seed, but we also, corn's a different one because it's a monoecious plant, meaning that it has male flowers and female flowers. There's a whole spectrum of different sorts of flowering plants, and not like there's a huge range of how they're going about all these processes. It's really interesting. Next bit, okay, flowers. Now, I've added in a little label here for us. So we've got male and female parts. Now I'm going to start with the male parts. So the stamen is what we use to collectively describe the male parts, the stamen. The stamen's made up of the anther and the filament. Now the filament is just this long stem that the anther sits on top of. Okay, now the anther produces the pollen. So the pollen has the genetic material, so half of the genetic material of the plant. The pollen would be the equivalent of sperm in animals. Now you'll see that we have this elongated filament. Now in self-fertilizing plants, so plants that use their own pollen to pollinate themselves, we will see that this filament will be up higher so that the pollen can fall down here onto the female bits. Okay, if it is not a self-fertilizing plant, we'll often see shorter filaments and stuff like that. In corn, all of the male parts are on the very top of the plant. Okay, so it's sitting up the very top. Because it's a monoecious plant, the corn cob itself is the female flower. So it has a male flower and a female flower. Now, we're looking here at our female part of the plants. Collectively, we call them the carpel. We have the stigma up the top, the sticky stigma. So it often is sticky so that the pollen sticks to it, okay? Then we have the style, which is this tube down here. So we have the stigma, style, and then we have the ovary. The ovary and the ovule. So the ovary is that bit around the outside, and the ovule is inside here, okay? And that's what our seed will be produced from. Now, what happens is that our pollen will be deposited either by wind, gravity, or by an insect, a pollinator, onto our sticky stigma. Now, a pollen tube grows down and around and up, and then the genetic material is deposited inside the ovule, and then we have fertilization take place. Now, it is a little bit more complex than that, but that's all we need to know for now. Once the genetic material has been deposited, we have an embryo is formed, okay? Now, at that point, we can have this ovary can form a fruit. So I want you to picture, this kind of looks like a tomato plant. So we have the seeds forming here, and then the fruit is formed on the outside. Okay, so when you're eating an apple or an orange, the fleshy bit that you're eating is actually the ovary of the plant. Okay, and the seeds are contained within that. Now, why do they develop a big ovary like that? That's often edible and sweet. Well, that is if that plant was to, the fruit was to drop, it is dropping a whole heap of nutrients surrounding the seeds that then support those seeds as they're germinating. But also it is a transmission adaptation. Okay, birds or animals will eat that fruit, and then they'll deposit those seeds out the back end in the poop. Okay, so it is a way for plants to disperse their genetic material. So I'm going to go over this again. We have the male part, which is called the stamen, and we have the female part, which is called the carpel. The stamen is made up of the anther and the filament. The anther sits on top of the filament, and it produces the pollen. Now, the females, the carpel is made up of the sticky stigma, the style, and then the ovary, and the ovule sits inside the ovary. Okay, so the parts of the flower, we've got a whole table for you here to fill out. I think the only thing that we haven't mentioned here is the sepals or sepals, and they are basically the leaves of the flower. Okay, I think you've got enough info to be able to fill that out. If not, it is on page 266 of Dynamic Agriculture. Okay, now this is the bit where we're talking about monocots and dicots. Now, we've kind of gone over a lot of this stuff. Have a look at our diagram here. The only thing we haven't looked at is the pollen grains, because that's a little bit more random. We don't really need to know that. But the main difference between a monocot and a dicot are the seed leaves, the leaves themselves. So we have this net-like leaf venation versus parallel leaf veins. Then we have a look at our vascular bundles on our stems. So our vascular bundles are nice and orderly in a ring shape on our dicots, and they're spread throughout the plant on the monocot. Our tap roots on a dicot, our roots on a dicot have a tap root, and our monocots have a fibrous root system. So they're the main ways that we can tell. We have some activities that you can go through here. It shouldn't take you too long. Now, realistically, I think that this week, so we've got 3.5 hours, we budget it. budget for your activities for a week, I think P1 and P2 should be able to be done this week, and we can move on for next week for P3. Good luck.